Today's somewhat irresponsible curiosity is assisted by Good Neighbor Brewing Company's Iced Coffee Milk Stout, Tahitian vanilla flavor. No tasting notes, but they do talk about the brewing process. It has milk sugar, cacao nibs, Tahitian vanilla, and cold steeped coffee from Little Sister Coffee Maker, also in Winnipeg. More than anything, it's the coffee notes coming through. So today, I'm going to be taking a look at this LED replacement fluorescent tube. It's an LED tube that replaces a fluorescent. This particular one is T8 size, and this is a weird imperial thing. T8, or the definitions are based on 1/8 of an inch, so it's 8/8 of an inch or 1 inch in diameter. Imperial, weird. Anyway, this particular one is broken. It's failed, and I'm not sure if you'll be able to see the failure mode. It is kind of subtle, but if you squint a little bit, you may be able to tell why it's not working, or at least why it's not suitable for putting into service. So since it is already half exposed, I figured it'd be a good one to take a look at the internals of. There is one end. The two pins just connect onto the circuit board there with a couple little capacitors in series, it looks like. Let me chop them out of there and we'll take a closer look. I'm not going to try and power this thing on because I don't have a ballast here. These were not from here. These are from a project that's being done somewhere else. But anyway, with that cap out of the way, I'll zoom in a little closer here, and yeah, it looks like those little, I assume they're capacitors. I thought those were capacitors, but no, they appear to be little fuses, less than half an ohm in series on them. Okay, and they are both functioning still, so that's not the failure mode. I mean, it's obvious the failure mode is that this thing has suffered from a deceleration trauma. So the voltage comes in from the fixture through those two pins there, and same thing at the other end, through these two fuses, and then we have resistor and two capacitors for each one. Goes to a couple of diodes there, capacitor, resistor, diode, and then onto the whole string of LEDs, which, as far as I can tell, appear to all be in series. It's very difficult to see on the board here, but it appears that there are three traces. One that goes down the outside there, one that goes down the outside there with test points, and then the one in the middle just has all of these LEDs wired in series all the way along. And I'm guessing, based on the marking, that there's 108 LEDs, being as how this one is marked LED 108. This one is marked LED 81, and then without getting out my x-ray, I can't see what's going on down the rest of this thing. Although I suppose I should use my x-ray on this thing to see if the other end is the same as that end. And then once I've got that done, I'll maybe draw out a schematic. And by x-ray, I mean, wow. There we go. Oh, there's different circuitry in that end. Let me just clean up this danger zone here. All right, time has passed, and as you can see, I have safely cleaned up the broken glass on this thing. Completely safely, no wounds, no bandages. Excellent. And I didn't spill my beer. So, in doing this, I discovered a few things. This is not one long string of 108 LEDs. It is actually 4 sections. LED 1 to LED 27 is one section. LED 28 to 54 is the second section. 55 to 81 is the third section. And 82 to 108 is the fourth section. So those 4 series sections are wired in parallel. And this power supply circuitry at this end and this power supply circuitry over at this end are almost identical. They're very similar. So I did also spend some time reverse engineering this to the best of my ability, and I have a few pages of schematic to show you. So we'll start at this end, which is the first end that we saw broken out. It has the electrolytic capacitor. So what's happening is we come in through these two fuses, which I didn't draw on here, terminals A1 and A2, which is what they're labeled on the board. Each side goes through a resistor, what is that, 510K resistor with two capacitors in parallel with it. And the other side does exactly the same thing, and then they join together. So those are going to be the same voltage coming in from the ballast. They go to these two diodes, the anode of one and cathode of the other. D4 passes through to a pad called LED minus, this one down here. And then LED minus carries on to one of the traces that runs the full length of the board. The other rectifier diode just carries on straight through to the far end of the board. And also this AC signal here carries on to the far end of the board. There is also a capacitor, that's an electrolytic capacitor, this one here, and that resistor in parallel with it, a 100K resistor, 100K, 104. And that has no other connections at this end, but it connects to the positive end of the string of LEDs and the LED positive pad test point on this end. So there are 6 traces that run the length of the board. This one just joins each of the LEDs in series, so it doesn't run the entire length, but it's just that little jump there. And there's 3 at the top there and 2 at the bottom. From the bottom, we have what I've arbitrarily called track 6, which comes from that diode. 4 and 5 are both the LED positive, so they also connect into here, and they are just wired in parallel. Then what I've called 3 is the series LED, 2 is the LED minus, this one, and 1 is this AC here. So now, down the middle of the strip, pin 3 is where it gets interesting. Pin 3 has the first series of LEDs from 1 to 27, and then the cathode of 27 goes up to the LED minus trace, which carries on, and it breaks. LED 28 picks up from the LED positive trace and carries on. Then there's a bunch of LEDs, and the same thing happens. I've just noticed an error in my drawing. One moment, please. So that carries on there. There we go. So as I was saying, we carry on up to LED 54. The same thing happens. The LED minus line picks up the cathode of this, and then the anode of LED 55 picks up the LED positive, and it carries along. And then at LED 81 and 82, the same thing happens, except for this LED positive line doesn't carry on. However, remember that this one is electrically in parallel with it. So then we connect to components at the other end of the circuit board, at this end here. We'll start again at the AC inputs, A3 and A4. They come through exactly the same resistor capacitor combinations. They go to 2 more rectifier diodes, these 2 here, and again 1 to the anode, 1 to the cathode. D8 goes to the LED minus trace that runs the length of the board that we were chasing on that other drawing. D7 goes into this little bit here. There's a resistor, a 36K resistor with a capacitor in parallel with it. And then that connects onto LED 108. What have I done? That doesn't look right. Those diodes shouldn't work like that. Let's just pretend that's a drawing error and you understand exactly what I mean. I've spent too much time on this. I don't want to go back to it. Anyway, but that also carries on here on the LED plus. Yeah, I've drawn that guy backwards. I'm not going to edit it. And that carries on the LED plus down pin 4 or trace 4 and carries on down there. This is the LED series. That one carries on down the board, and this one also carries on down the board. But that's hard to see, so let's just simplify it a little bit so we can look more closely at it. Stripped down to its most basic, here is the power supply section of this thing. We have live or neutral coming in at either end, it doesn't matter. We have capacitors here, a couple of them in series, but that essentially makes a capacitor dropper. The resistor is a very high value resistor, so it's just a drain or a discharge resistor for those. It's not really doing anything other than making it safe when it gets disconnected. So those come in here too, these 4 diodes. Does that diode look familiar? That configuration of diodes look familiar? If you've ever heard of Electroboom before, you'd know that this is his favorite full bridge rectifier. And it is just simply rectifying the AC into DC and putting it out to the LEDs. I've omitted other things. There are some steering diodes. There is another electrolytic capacitor to smooth it out, but that is the absolute basics of what's happening in this thing. So that is an interesting little thing. I had wondered how they deal with the voltage coming in from the ballast, which is, I believe, transformered up to a higher voltage. I'm not 100% sure. I've never taken apart a ballast, but yeah, I believe that's what's going on in here. And these LEDs are just standard 2.6-ish volts. Let's call them 3 volts, just nominal LEDs, just very common LEDs. 27 of them in series. You get about 70 volts per section. So that is what the power supply is dropping it down to, which if they weren't on an aluminum core PCB might be worthy of salvaging, but since they are, that's not really going to happen. So all in all, yeah, my curiosity is satisfied, and that is really what I'm doing in 90% of these teardown videos, is just satisfying my own curiosity. And I hope that helps you guys as well to satisfy yours a little bit anyway for things like this. You see them in the wild. Maybe you don't have a chance to take them apart yourself and satisfy your curiosity. I hope that I can do that for you. Well, thanks for watching. As always, questions and comments down below. I will talk to you later.